So welcome after the break. And first question, how to monitor only one particular session? Very important from developer point of view and also administrator point of view. Imagine you have been just called by an angry customer who is keep telling you that everything is slow. I am connected, I'm trying to work, and everything is slow. So if you can only identify the session number, you can use extended events, which is a modern, lightweight mechanism to trace SQL Server activity. And using extended events, you can find the weights that are associated with this connection. And I will show you how to do it. Please use it and configure it properly, as you were configuring SQL Server Profiler. Because if you turn on everything, you will be really flooded, because you can see how much events are generated during normal, let's say, SQL Server activity. What you should observe: there are two events, both placed in SQLOS package. First, it's called wait info. Exactly, though there are two events. One is begin, one is end. So we have to count only one of them, yes, or begin or end, not to count them twice. And if you are interested in so-called preemptive waits, you have to monitor SQLOS.waitInfo external. Preemptive means that SQL Server has to call Windows for something. Okay, so how to do this? Quick demo, because we have to move forward to wait types, actually. So, extended events. We all know AdventureWorks 2012. I try to set up this event session. I will observe only wait info event, so only the internal events of SQL Server. This is the session number that I will identify in a moment, and I will write the information into the file. So first, what I'd like to do is to delete the old files, because I has just remembered that I have already one from today's morning. So this is the setup of event session. Then we start it, and in the other window, I will run the actual query, and I stop again the session. So the query is pretty simple. This is it. So what I will do is I will rebuild all indexes on a particular table, and that's all. And we will see how many events we are generating. So what is our session ID? Should be 53. 53 here, 53 here, okay. So I change my event session definition, and we can go. The session is defined. I'm starting it right now. In the other window, I am rebuilding the index. It will take 2 seconds, okay, or 3. So I stop the session again. Again means it was started and that it is now stopped. And I have a system function which is called fnxe file target read file. This function allows me to read the files. And I will count what is inside. So we have 1,533 events for just rebuilding indexes. So I will put the information about event data. Event data is the function, is the information that is the XML that holds information about those events. I will store it in the temporary table, so then I can manipulate it as I like to do. This query that processes this event data structure was written by Jonathan Kehayas. I'm not going to reinvent the wheel, you know, it's not, it's a waste of time to reinvent queries one more time when you can find the good queries in the internet, especially if a person is, you know, that person who knows SQL Server. So as you can see right now, for example here, we have page large which begins and ends. So we have to count only, let's say, the end of the events, and we can then count the duration time, for example. As you can see, the structure of this let's say, query is very similar to what we have seen previously for weight stats. So the query was prepared to display such information. So now we can do this. We can run the query. And what you can see that CX packet was done 36 times. So it was a parallel operation of rebuilding the index. We have SOS scheduler yield. So the thread was stopped for a while and moved back to the runnable queue. We have page IO latch because we have to load all the data. We have latch AS, shared latch, the number 4, which is a physical protection over non-data pages. Page latch, update latch, and also some less important weights. So the most important was CX packet here in terms of wait time, of total wait time. Okay, so this is how you can work with a particular session. You can examine what is going on with this particular session. If there was a problem with this session, maybe you can find a solution, but probably you will be only close to the solution, or you will have the knowledge what is going on with this session. Okay, it was wrong slide. I should run not the first, but now is the second part of our lecture, weight stats across the world. So imagine that in every country there are a lot of SQL servers, and Paul Randall, which is my favorite author, make let's say a poll that 1,800 people sent him his data from their SQL server. And in the year 2010, the data in terms of weight stats, the most important was CX packet. Have you expected something else to be on the top? Probably no. CX packet is the most dominant one. The second one was page IO latch, async network IO, Rightlock, etc. So about all of those, I would like to tell you in the next part of the presentation. Similar poll was done in May this year, and the only change you can see is that there is an OLEDB on the second place. Strange, why OLEDB is on the second place? And Rightlock, okay, leave it as it is. And latches are a little bit down in this hierarchy. So Paul Randall made a summary that really the OLEDB is now 17%. However, 4 years ago, in the year 2010, it was only 4%. So why it is you know, the gain is so much? We try to explain what's going on with this. Rightlock has increased, async network IO has decreased. So we can guess what's going on with the async network IO on the one of the latest my demos. And page IO latch also decreased. We can connect, maybe we can connect sometimes those two, but not always. Please remember that there are a lot of weights that we are not interested in. I show you in the query, there is a slide. We should not analyze them. We should get rid of them from our analysis, from our query. Because there might be not a weight, actually. There are only signals that someone is waiting because it has nothing to do. CX packet, don't panic. Probably you see a lot of CX packet on your processes. So it's perfectly okay that you can see it if you have more than one processor in your server. Probably all of us have more than one logical core. Yes, it's hard to find an instance where only one. Maybe on SQL Server Express, but this is something else. So that's okay that we have CX packet. This is normal operation because in a query runs on more than one core, we have to have CX packet because it's normal. I will tell you in a second why. However, if you observe that the CX packet is rapidly growing, that this might be an indication that something is wrong, and this might be a problem. don't follow the dumbest recommendation on the internet. The dumbest recommendation in the internet is set the max DOP to 1 on the whole instance. I found it actually. So don't do this. You will effectively turn off the parallelism, but you can slow down the entire server. However, you will eliminate the CX packet. So if this is your goal, this is the perfect solution. Of course, it was a joke. Don't do this.
Unless you're running Microsoft's systems like SharePoint or...
Okay, this is something, yes, totally different. What is CX packet? This is a table. We are going to scan it. As we are living in the perfect world, we have perfect statistics. We have 4 threads. Each of these threads will scan this same equal size of this table. This thread number 0 is like a manager. It does nothing. It's just sitting there and coordinating. Yes, but without doing any other work. So the task, every of these threads are running. And if we put together those arrows, so we see that they end their work approximately at the same time. In ideal world, it is the same time. They started and finish at the same time. So where is the CX packet? It's there. The thread number 0 is so-called coordinator thread. It's just coordinating, like a manager, yes? Maybe it's not screaming on other threads, like managers do, but it's coordinating. So this is CX packet. So where is the problem? This is normal situation without any problem. We just have the CX packet because we have run the query on multiple cores. That's okay. The problem is if we have some part of the table which is bigger, and for some reason SQL Server does not know about this. It assumes that all those parts are equal. When this could be? When this is the real situation, yes? We have ever increasing key, for example, auto incrementing key, identity, and we have not updated statistics, or the automatic statistics has not been started yet, because there is not that big change, yes? So SQL Server does not know about this part. It thinks that every of this thread will still has the same amount of work to do. So now we can see that the thread number 4 has really more work to do, has to scan more data. So in that case, when thread 1, 2, 3 ended, they have to set the CX packet, and the coordinator thread has the CX packet from the beginning till the end. So all of this right now is CX packet. So this is example of rapid growing. In previous example, the CX packet was that large, and now we have 1, 2, 3, 4, 5. So in this example, the CX packet is, let's say, at least five times bigger than previously. So it's rapidly growing. So what could be the problem here in that case? If you can see also page IO latch, that indicates that we are going to do a table scan. What means table scan? You have to read all data to the memory. So maybe we don't have a proper non-clustered index for our query. If we have to scan a table, maybe there is no proper index. Maybe the plan of a query is not optimal. It was optimal previously, but now, in this moment, it's not. So please refer to the OS waiting task view and the query I shown you, where you can dive to the query plan. Or maybe just statistics are wrong. So what I would do, I would take a look into statistic first. I try to update it, I will examine them, dbcc show statistics, and try to find the solution. Maybe I can find better indexing strategy. Maybe the indexes that were created some time ago are not longer valid. We should create another one. And the max DOP. Max DOP is always a solution, as I shown you, because you can set it to 1 and turn off the parallelism. Those are some recommendations. Don't follow them. So set max DOP to 1 if CX packet is the most important weight on the instance level. Set max DOP to 1 if you have OLTP system. set max DOP to half of number of physical processors. I don't know where it comes from, this recommendation, but I found it already. And to set max DOP to number of NUMA nodes. Okay. Fact, there is no good strategy to setting max DOP. However, we can find a good recommendation. Recommendation is always that we should try to identify the worst performing queries. And if you would like to turn the parallelism off, do it only on those queries. So you can put the max DOP hint on the particular query. Sometimes you can set the max DOP to 1 on the instance level, but you have to test it. It's not the first rule you have to do. I had once a situation that it really helped. It really helped. It was the last solution, and it really helped. If your system is let's say mixed one, so you have some reporting, some OLTP, and also analysis, you can't set the max DOP to 1 on instance level, because you will lose here on reporting. Reporting are, this is parallel operation, yes? Column store index. So parallelism is really welcome in this operation. So if you set max DOP to 1 on the instance level, your server will be really, really slow. Please identify the queries, and if you have resource governor, you can set the max DOP limit on a particular I think resource pool, and these settings cannot be overridden anywhere. So this is the last moment when you can set the max DOP. Okay, of course you can check always the statistics, and the last thing is that you can consider changing the cost threshold of parallelism to higher value. Right now it's 5. You can set it more, you can set it to 20, to 50, but please be careful with that. The demo, do it on your own. There is a code and instruction how to do this. This is a SharePoint-like table. I have a SharePoint table, let's say a table designed for SharePoint, which is not the best design, as you know. SharePoint is not the best product with best design database. So in this database, when you're decreasing the parallelism setting to 1, you will see that everything is very slow. If you set it to max, let's say my laptop has 8 cores, it is really faster. As we do not have much time, so I skipped the demo. This demo has number 5. You will find it in the code. It's pretty simple, so you can run the demo. OLEDB, that was the second part. This was the second dominant weight on a list that Paul Randall prepared. Why it is there? OLEDB initially is connected to link server. So if we just leave this sentence without others, that you could imagine that many people started to use link server between the year 2010 and 2014, and they do something wrong if OLEDB is so high in the list. However, for example, DBCC CheckDB also uses internally this OLEDB to connect to read the data, to have access to data. Also, many of the database dynamic management view also uses internally OLEDB. So if you have a third-party solution like a monitoring tool that queries your DMVs, so then you can see many OLEDB weight stats. So it can be because you are using monitoring tool from, let's say, different companies. So that could be the problem. That could be the problem. And of course, link server can be a problem because then you have distributed transaction, and if it is poorly designed, it can lead to a problem. But at first, maybe you are doing DBCC CheckDB, which is a good, yes, to have this in your maintenance plan, because then you are sure that the database is consistent, let's say. Maybe you are using some monitoring tools, and the link server is the third diagnosis. We have seen also the Rightlock constantly. So it pop-ups when we have to wait, when SQL Server has to wait for a transaction log block when it's flashed to disk. We have to wait before we flash it to disk. This is we should not assume that there could be a problem with I/O system, but probably it is. In most cases, it is. You can do a demo. You can put USB stick to your laptop, put the transaction log on it, and you will see that the write log will be always the top one, because USB is very, very slow. Then you can create the database on your normal hard drive, and it should be way more better. And if you spread data and log among many disks, it's the best solution. What could be there also? If you see write log, don't create additional transaction log files. Do you know why? Okay. So, if you would like to see if this is really an I/O problem, you should correlate this wait time from write log with information you can find here in sysdm IO virtual file stats function. You can pass file number, and you will see there is a column information which is called stall time. And if the stall time, average stall time is really high, that you have a problem with disk, and you should consider to do something. Maybe faster disk is better then. You can correlate it with log buffer wait stats. If you have those two on higher value, that there might be an internal contention in the SQL Server in log buffers. You should consider, you should look at the average size of your transaction. The problem with write log is when your transaction is very, very small and very, very fast. Like in my example, I have only inserted default value, nothing else. For every transaction, when it's completed, it has to be flashed to disk. Transaction log has to be flashed to disk. The minimal size is 512 kilobytes. So even if your transaction is small, you have to flash much more information to the disk. This is the log block.
You mean 500?
Bytes, sorry, bytes, yes, bytes. But the transaction is, in my case, it's really, really small, yes? It's only insert the integer value. So let's say 4 bytes plus something, 4 bytes plus something, and 512 bytes that must be sent to the disk. So if you have a lot of such short running transaction, that could be a problem with write log. Okay, this is really a problem. Try to look at this disk write queue length for the drive where you have transaction log. If the query is constantly around 31, 32, then you have a problem, because a SQL Server has hard-coded limit of 32 outstanding transaction log writes to a single database. So if you have more, then you just can't operate. And this is a real problem. And this can lead you to the situation when you have to create another database. Or you can do something else. The details will follow. Write log often occurs when you have page splits. Page splits means that that the index level has to split, the data level has to split to another page. So the solution, use better disk like SSD. It's obvious, yes? Watch out, make the transaction take longer. This is not what you like to see in the OLTP system. But if you have problem with logs, with transaction log, with write log wait stats, maybe you can try to make the transaction to take a little bit longer, or try to lower down the amount of transaction, or maybe you can set not 200,000 transaction, maybe only half of this, yes? Maybe you can do something with the application or store procedure or something like this. Take a look at non-clustered or non-used indexes. If you have a lot of indexes that are not used, still SQL Server must maintain them. So every operation, let's say insert, update, delete, can affect all indexes. If you not use them, just drop them. Just drop them. And the last, almost the last will be, if nothing can help you, you have to think about new database, because the 32 outstanding transaction is the hard-coded limit. And if you see this, probably your server is down. You can play with the fill factor, which leaves some free space on the page, so maybe you can avoid page splits. Okay, now we will see the demo, because we are going to be talking about page I/O latch. We have three types of latches which are interested in our case. First, it's called page I/O latch. It's when you try to load data from disk to this memory. So latch is a physical protection of the buffer. Lock is a logical protection, because you have your data to be transactionally consistent, and latch means that the buffer must be physically protected. So where you put the data, it must be physically protected. What is the difference between, in some level, between lock and latch is that you can lock a particular row, so only one row on page. However, you latch only the whole page. So even if you are locking single row, you have to latch the whole page. This is important. We have different modes of the latch depending on what we are going to do with the page after it's loaded. If we are going to read it, it will be page IO latch _sh, means shared. We can of course update, and we have exclusive. That means we are going to change, delete, etc. Please do not assume that this is an I/O problem at first place. What could be else? This is reading data from disk. Indexing, yes, this is the first. Haven't you seen my presentation before? Because you guessed, okay. What index are used? If we are using bad indexes, then we have to, for example, scan the data, yes, the whole table. So we will see bunch of page IO latch. We should correlate DM IO virtual stat and correlate this with perfmon counters, like these seconds per read. We have to check if those two latches I showed you before, CX packet and page IO latch, if they have, let's say, high weights, because that can mean that we really do a table scan. CX packet plus page IO latch means that we are doing a parallel scan, which is pretty obvious situation, unfortunately. What indexes are used? Probably we are scanning table without, and we should seek the table. So probably previously we have designed an index which should do a seek. However, during the time we are scanning. For example, we are not seeking on non-clustered, but we are scanning the clustered index. Maybe we are doing a data conversion. That also implies page IO latch. And of course, that could be some problems with memory. For example, buffer pool is too small. Maybe we have too small memory installed on the server. So there is no memory to store the whole result. So we have to flush the pages, the buffers to the disk, and we have to load fresh pages from the disk again to memory. So page IO does not mean at first place that there is problem with IO. That could be a problem with memory. You have to check page life expectancy. But the level 300 is no more valid. There is a mathematical rule. You have to find it. What is the expected page life expectancy in multi-core environment in 64-bit for 64-bit SQL Server? So let's do the demo, because I was talking for 15 minutes already. Page IO latch. Is it a beer or a Coke? It must be a beer. Okay, page IO latch. So, page IO latch. First we clean up the buffer. And now it's a real exam for you. You know that what else apart from page IO latch should we see in the weight stats? What do you think? OLEDB, I was talking about this. So you pass. And what else? What else? I clean this. I clean this. I told you a minute ago that what this operation has to do, it has to load the data to memory. So this will be page I/O and the DBCC work in parallel. This is a trace flag that you can turn off the parallelism of DBCC checkDB. However, in normal, let's say normally it works in parallel. So we are scanning now the Adventure Works 2012, and I'm trying to find the problem. So CX packet, OLEDB, and page I/O latch is here. Was it big? No. It's only, this is 1 millisecond, so it's a, let's say, a fraction of millisecond. We waited 4 milliseconds for 4.5 to satisfy the CX packet. Was it bad? I think no. We shouldn't care. We shouldn't care. If you run the demo with CX packet, you see that the CX packet is 0.20. This is something really dangerous, yes? If you have to wait 200 milliseconds to the query for the wait or for the resource, this is really wrong. In that case, it's only demonstration where you can expect page I/O latch. SH means that the pages were only written because they will not be changed. DBCC will not change, or at least this definition of DBCC, because we can always have another option, yes, that tries to fix corruption if find one. However, it's not used in that case. So we have page I/O latch. The page latch, as I told you, this is something which is when you loaded the data to the memory, then the physical protection is manifested by the page latch. So do not confuse it with page I/O latch. Page I/O means disk. Page latch means that you are protecting data buffers. If we are going to protecting non-data buffers, like an intermediate level of index or root level, we'll see latch without the page at the beginning. So latch is for the non-data pages. Page latch is for data pages in memory. Page I/O latch is for the data pages loading from disk. So now you see how it correlates. Okay. If you find this, and this is, let's say, excessive page latching, you can find what pages are affected and try to identify the table. It's pretty simple. Then you can analyze the queries that are connected to this latch. Okay, so the most famous latch, page latch, was found in TempDB. It was a TempDB contention. I think you know what am I talking about, yes? The problem is that the TempDB database is used in different way than normal user databases. We are creating work objects. They are small. Probably they are small. And the problem is that we have page latch contention of 2 pages in TempDB. The first one is page free space, which must be constantly updated, and the second is the shared GAM. So if you are creating multiple small TempDB objects from different connection, all those threads would like to update those 2 system tables and have to wait. So the best workaround is add more TempDB data files and enable trace flag 1118, which effectively works for all databases, but has only effect in TempDB. So if you set it on global level, every database has the trace flag turned on. And also the last recommendation could be that we should reduce temp table usage. However, the problem might also be like it was on the example when I told you that the CX packet is a problem. Then we find that we have ever increasing key. So we're inserting data on a key that constantly is growing. In that case, the last page when we inserting data must be blocked by page latch exclusive, EX. So any other connection is blocked for a while until the latch is lost, yes, is released. So if it is a problem, it could be a problem if you have thousands, hundreds of thousands of transactions per second or more. It could be a problem then. Then you have to think that maybe you have to change the key. Maybe you should use a random key, like a GUID, for example. Yes, it's not usual recommendation, but you have to think about. Or some kind of composite key. This will allow the hotspot, so the last page will be then spread out across all the table. It's not the best solution, but already it is. Of course, there might be a solution. This page large is also in scenario when page split occurs too frequently. So we have random key, already random key, and inserting data causes that the page has to split. So not only the data page must split, but maybe on the intermediate level too. So then we have to change the key from random to be non-random. So totally opposite to this. So you see one weight type and two different interpretation, depending of what is going on your system. So I will show you the demo. 7 minutes. Okay, we can do this. It is the first example about page large. Is the first example we have seen. So I can clear it. I can create the. Yes, sure. I'm just cleaning up the database. So it's nothing interesting right now. The database is created. I'm running the 20 connection. Okay. I'm running the 20 connection where it is. It is here. Encode here. Start 20 connection. And we have to examine waiting task, let's say. Okay. See, there is page latch. Do you know what's going on? I'm inserting default value. This is every increasing key. 1, 2, 3, 4, 5. I'm inserting, and you see that there is contention of on the last page. There are 19 connection, 18, 19 connection. That they are trying to insert the data. However, only the one is able to do it. Yes, if the first one finish, next the second one is allowed. So we will see something like this. We see how to identify. I've just identified for you a database, a file, and the page number. 748 is the page number. So you can then having this page number. You can go to dbcc int or dbcc page and examine what's going on this page. Oh, 5 minutes. Okay. This is the query. This is the query plan, and that's all. This is end of the demo. This is end of the demo. So having a key which is doing something like this, I mean, every increasing key is better, is the best solution in many cases. However, this usage of our database is, many transactions in very short time can lead us to the solution that we have to change the key to be more random, to be more composite. Async network I/O is the last thing I would like to present. Async network I/O should tell you that there is a problem with the network, which is not actually, even though the network is presented in the name. What does it mean? The SQL server waits for acknowledge that data was obtained by client application. So we just run the query, we have the result, we'd like to send it to the client application. And the SQL server is sending. So whilst it's sending, it has to set the async network I/O that I am sending, and is waiting for acknowledge from the client application that it can send another portion, because the data are sent in packets, yes? Not the whole result, but in packets. So if the client application, okay, that's what I already said, if the client application processes the data row by row, so we have to wait a little more, yes? If you take not the whole set, but row by row from the set, then you have a problem. SQL Server has to wait. This is called row by agonizing row. This is the term you can find in internet, R-bar. So when you are processing data row by row, so like a cursor, then SQL Server has to wait. Do you know the most famous application that behaved that way? SQL Server Management Studio and the grid. I will show you it. Okay, this is the last demo. So I have 3 minutes, so I can spend it on Management Studio. Duplicate.
You can take some extra minutes as well.
Okay, so I have one more demo about logs.
If that's okay with you guys? Yes.
Okay, I turned off my network connector. What can we see? Wait stats, for example, we can clear it. So what I can do here, this is the client application here, yes? I'm scanning 2 tables, I'm cross-joining them. The table has 500,000 of rows, cross-join with other 500,000 of rows, so it's bunch of rows. I don't know how much is that, it's bunch of rows, yes. It's that much that I can analyze what's going on the server. So let's try to do it. What I'd like to do, I run this first. So first, waiting tasks. Let's check what is on the waiting task right now. We see a wait which is called preemptive. Preemptive OS wait for single object. Do you know what is this? Because there will be only 2. Preemptive or async network I/O. See? Only those 2. Oh, where is the second? It was async network and preemptive. Only those 2, nothing more. So what do you think, what is this? There are a lot of preemptive waits. That means that SQL Server asks Windows to do something. Ask Windows to do something. And the something part you should read from that point. Wait for single object. All those preemptive waits will have the name preemptive _ OS _, and then the name, there is a Windows API call. So if you open the MSDN and write wait for single object, you will see what does it mean. And depending of the name, you will have to find proper strategy if this is the most dominant wait for you. We are waiting for SQL Server Management Studio. That's okay, because this is what it's actually doing. This is the query and the plan. So I switch back here to show you something. This is what I'd like to see. Those 2 in the beginning, 50%, 49%, so it's 99, almost 100%. This is when SQL Server is ready to send data. It's waiting to send data. And this is the synchronization mechanism. It is waiting from response from Windows that the application is ready to have the data. So this is internal waiting, and this is external waiting. This is the handshake. Write file gathers, there is another preemptive. We have to do something with the file. Probably we have to write something to one of those files, but the percentage is so small. So this is the problem when SQL Server Management Studio tries to render the grid, which is here. It is rendered row by row, one by one. And this is the problem. So SQL Server Management Studio has to take the next row and signals that it's ready. So the signal is the preemptive wait. I'm ready. So Windows then signals to SQL Server, send the data. So this is the preemptive OS wait for single object wait type. Okay, what is also very funny that we have session 52. This is no more interesting. We can go and deep dive a little bit more, for example, to other data management, dynamic management views. If you go to the exec requests, you can see that this is a SQL handle. This is a SQL handle when you can then navigate and find a plan. This is a plan handle, so you know what the query is. We should see what is actual wait type and what was the previous wait type on this particular request. And what else? What is important? How big is the CPU time? This is the task address. I will copy it. I will show you in a minute what is important. We have some information about logical reads, writes, etc. But let's go to the task. What is important here is the state of this task. It's runnable. The important part is this: context switches count. What is a context switch? The context switch is if you are running SQL task and you call Windows to do something. So you are switching between threads. And this is context switch count. The higher the count is, let's say the slower the process might be, because you have to call external Windows API. So take care also about these context switches. This information is pending I/O count. So we have 215 pending I/O still to do on this task. And if we go to the worker, which is task is the thing we have to do, and the worker is the guy who actually is doing the task. So here we can also see that at the moment I queried the dynamic management view, I can see that the is preemptive is changing. Right now, at this moment, the task was working on SQL Server. However, when it's run, it is working on Windows. Yes, we have Windows call at this moment. Why it is important? When this task is running on Windows, its status is always running, because SQL Server does not know if Windows is doing something or not. So the only way is to set it running, not move it to runnable, not move it to waiter list, because Windows is controlling the task. Okay, so it was the information I wanted to share with you. Okay, so you can try it on your own. Normally, you don't have to go that deeper to analyze what is going on the waiter, on the workers, and on the tasks also. I have two more slides. One is about all about locks. So sometimes, and we can see also this type of wait type. It means there is a lock of type. This type XX can be exclusive, can be shared, can be updated. This is lock when we are waiting. For example, to access to a data. This is log. This is logical things. We'd like to read the data which are, for example, updated in the moment. So logs can be incompatible. So we have to, one of those threads have to wait. We should not think that locking is the problem, the main problem. Please go to this waiting task and try to find what is blocking this task. You can see in this column blocking session ID that maybe someone else blocking us. And this might be the real problem of the situation. If you have really excessive locking, for example, you can see much of them. You can try to introduce, for example, partitioning. Maybe you should review the indexing strategy. Maybe non-clustered index are not used as you expected, for example. Maybe you can break your updates into smaller transactions, for example, or you can try to find if snapshot isolation or different isolation level can help you with this. So let's check the demo. This is really the last one. This is really the last one. So if you have 2 minutes, we can do it. This is, this is pretty simple demo. I try to insert one value to this particular table, which is no, this is insert, I believe. Yes, I mean, so. Oh, I thought you are talking that I am changing the value. However, I can see insert, so that's why I have to check if. Okay. Now it's okay, it's insert. So I will be inserting one row to a table, and I would like to see waiting task. Waiting task, yes. And in second window, I would like to read the data. So let's run the transaction. Of course, in this window, it's not possible for me under this isolation level, which is default one, read committed. I can't read the data, yes? I can't read the data, so I can see what is on my waiting stats. I'd like to have a log which is type of S, because I'd like to read the page from the second window. From this window, I'd like to read the page. However, at this moment, I am blocked because this transaction is in progress. I'm inserting data. So, this is a resource description. So, you see that you are blocking by session 52. So, you can find out what is session 52. But here you have some information, further information, what's going on. So, if we copy this, so for example, this is from syspartitions view. We can try to find, I believe there will be something there. Yes, we can try to find what is the object. So you can find what is the object, what is the table, and how many rows is there right now. So you can, this is the fastest way, in my opinion, to see what is going on. But believe me, that the description, what we found here, is not always that clear, because we can see that there is right now that there is mode X on this page. This is the log description. This is the log description, and this is the same object in that case like this. So this object is blocking probably this object. So we can't read. And that's basically all. What is all about. So if you see pretty much logs, you have to then investigate if your indexes are okay, if you have long-running transactions whilst trying to write data or read data to another part of the table. So that's all in terms of logs. I already told you about the preemptive weights. So now it's time to make a quick summary, and it's very easy. We have to diagnose. However, it might not be easy. In many cases, it's not easy to have the good diagnosis. My advice is be careful when reading advices found in the internet. Yes, if you know. Because you can find some very, let's say it, hairy advices that you should turn something on off. Try to verify them, try to test them, and of course ask questions. If you have doubts, please ask questions, because there are a lot of advices that are not working and can lead you into serious problem, I believe. In my opinion, the best way is to practice and learn, and of course learn by practice. So take the SQL Server, take your personal instance, and try to kill it as I did today with you. So try to find out what you can do, and you will learn how SQL Server behaves. This is, for example, a very good set of resources. There you should see a bunch of very good information for the topic, let's say wait stats, CSS escalation block, which has really good information there. So please read them. In my opinion, that one is the best white paper ever that introduces weights and queues. So start with it. If you have more information, those are a little bit more complicated. So that was my last sentence. Thank you all for coming here. One more time, it was a very good pleasure to be today with you. I hope we can meet again during next meetings, for example. Thank you very much.